1E. Determine whether each of the following pairs of angles have equal measures. Okay, KJR. If you notice this, you've seen this picture before, right? MJP. So the great news is you get to use this picture on all of these problems, A through E, and the numbers aren't going to change. So when you see an arc like this, arc on the 48, then you know this one is also 48. So one of those angles, this one right here, 48 plus 46, that's 94 degrees. Now, some of you might have been wondering, is PJK a straight line? Because if it was a straight line, well, and MJR was a straight line, then they'd be vertical angles. Then they'd be congruent. But I don't think either of those are a straight line. And we can find out if they're a straight line. What we're going to do is add all these angles up. This one, this one, this one, this one, and 90. We're going to add them all up and subtract from 360. So you add them all up and you get 278. 360 minus 278 is 82. So is 94 equal to 82? That one is a no. So no, PJK is not a straight line. And we already can tell that because those angles don't add up to 180. Number 3. The bisector of an angle is sometimes on the exterior of an angle. So let's speak a little bit about what an angle bisector is. So we have an angle. First of all, an angle bisector is a ray. Okay? It's not a point, it's not a line, although a ray is part of a line, but whatever. It is the ray that divides, did you hear that? The ray. So there's not more than one of them. Like here, there's not more than one of them. It is the one and only ray that divides an angle into two congruent angles. So for any given angle, there's only one ray that is going to split that angle perfectly down the middle, perfectly in half. You can find an angle bisector by measuring with a protractor. You can find it, you can construct it with a compass, or you could even take your angle and fold it with your paper. Put one ray on top of the other ray and crease it. You'll have a nice long crease. You'll have a crease on your paper. If you fold and put this one on top of this one at the vertex and you pinch it. So there's lots of ways to do that. Will the bisector ever fall outside the angle, in the exterior of the angle? No. The angle bisector will start at the vertex and it will continue on forever in the interior of the angle. This blue one is the angle bisector. It is always in the interior. Okay, number 6. Angle 1 is 3x plus 5, and angle 2 is 2x. We don't want to forget this all-important information up here, although we could almost solve this without it. Not quite. APC is a right angle, and you know what? I'm going to stop right there, because knowing that APC is a right angle is enough to solve this problem. So, what we're going to do is not set these equal, because I don't see the word bisect. I don't see anywhere where it says angle 1 is congruent to angle 2. So we're not going to set these equal. Instead, we know that these are, vocab word, complementary. These are complementary. So we know that the measure of angle 1, which is 3x plus 5, plus the measure of angle 2, which is 2x, equals 90. Part equals whole. 5x plus 5 equals 90. 5x equals 85. X is, I want to say 17. Yep. X is 17. And then it wanted angle 1. So you take the 17 and you plug it in right here. 3 times 17 plus 5. 56 degrees. Number 10. PQS. Ooh, that's the whole thing. Is x squared minus 5. PQR is 45. And RQS is 5x. Remember what we talked about. We do not make you very often factor on a major grade, on a test, but it does show up on daily grade. Okay, so what were your two answers, Asha? Part plus part equals whole. Move everything to one side. So let's see, is it 10 and 5? There we go. So x is 10 and negative 5. So this is where we decide whether we keep them or not. Do we keep one of them? Do we keep both of them? We don't know. So the thing is, we're asking for PQ, that's the whole thing. Can you plug 10 in here and get an answer? Yes, 195. Can you plug negative 5 in here and get a positive angle? Yes, you can, but you have to be careful. It has to work anywhere in the problem, and it doesn't work here. 5 times negative 5 is negative 25. So if it doesn't work in even one spot, it is not a good solution, so you do have to throw it out. Okay? All right. Last one, and I'm not going to do this with a compass for time's sake, but I will describe how one might subtract with a compass. Okay? So the first thing you would do is draw yourself a ray. Then you would make a copy of angle A. You would make an arc, and then you come over here and make the same arc. And then you put needle, pencil, needle, pencil. And then you come over here and put your needle here and make an arc right there. Pretend that's equal. So you copy angle A. Copy it. That's step 1. That was the first thing we learned how to do, is copy an angle. Now to subtract them, you're going to copy angle B. And preferably, it's harder to do, but preferably you would copy angle B onto this ray, and you would have it coming out like this. This would be angle B. You see what I'm saying? You do the whole copy thing, all the steps. And what's left over would be your answer. This angle right here would represent angle A minus take away angle B.